Okay, here are the answers to the midterm take-home exam that you can follow along with me. Let's see, first question up says to find the converse of a sentence, of a conditional sentence. And the trick there is to remember that a converse is where you have to move both parts of the sentence around. Just as in a conversation, your words are traveling, with the converse, the words are also traveling. So we're looking for the one that matches that. So the meaning's not going to change for each piece. It's just they're going to be rotated. It's choice 4. There's other ones to remember too. The inverse is when they change meaning in both parts. The contrapositive is when they both switch meaning and switch position. For question number 2, they're asking us to find out if these two lines are parallel, or are they the same line, are they perpendicular, or are they none of the above. And to do that, if you follow the hint, it gets you started in the right direction, is to get y by itself in both equations. So subtracting 6 from both sides for the first equation gets things started, then dividing by 3, you get y equals 2/3 x minus 2. This puts it in slope y-intercept form, and we can locate the slope for the first equation at 2/3. We want to find the slope of the second equation, so you want to get y by itself there as well. You could begin that by adding 3x to both sides and then dividing both sides by 2. This gets you y by itself, and remember, once the y is by itself with these linear equations, you can locate the slope. The slope is the number in front of the x. Now when we compare both of these two slopes with each other, we see that they're not the same slope. So if they're not the same slope, they cannot be parallel, they cannot be the same line. Are they perpendicular or are they not? Remember, for them to be perpendicular, they have to be negative reciprocals, the same fraction flipped, which it is, but with a different sign. These are both positive slopes, so they are not perpendicular. These are just intersecting lines and not perpendicular. You could also get the answer too, remember, by just graphing each of these equations in a graphing calculator and seeing if they make a right angle or not. For question 3, it got cut off on my paper here. You're looking for which of the following segments are congruent to BC. And you could draw a picture of 3 triangles and label them, but the easiest way to do this is just play it as a matching game. We're looking for the one that's congruent to BC. In this congruency statement, it's all set into a particular order, so the answer would be either ST or KL. I'll flip to the next page and find out what it is. So it would be ST. Oops. Alright, for number 4, we were looking for the one that is not a right triangle. Well, if it's a right triangle, the numbers will work in the Pythagorean theorem. All of these work in the Pythagorean theorem, but choice 2 does not, because if you try to put the numbers in, you end up getting something that's false. You get 4 plus 9 equals 16. And 13 does not equal 16. So this would be the one that's not correct. Alright, number 5. There's a lot of mistakes you could make on question 5. The hint that I give is pretty thorough. Do not just add these all together and make them equal to 180. If they were 3 angles inside a triangle, then yes. This one is the exterior angle theorem, which says that the outside angle, the exterior angle, is equal to the 2 remote interior angles added together. So the correct setup on this question is to just do that, is to build your equation from that fact. So you get 6x is equal to 3x plus 10 plus x plus 40, which altogether gives you 4x plus 50. Continue solving for x, and you end up getting that 2x is equal to 50. Divide both sides by 2, and you get x is 25. And a student that's working too fast might look at the 25 and say, yay, I found the answer. But in this question, it would be a bad thing to do because they want to know what the angle is, angle CAB. Angle CAB is this fellow right here. And angle CAB is x plus 40. 25 plus 40 is 65, and that would be the correct choice. Okay, looking at question 6. Question 6 is a pretty difficult question. One suggestion I gave in the hint is to use the last page of the exam and get a scrap sheet of graph paper out and actually graph this so you can actually see it. That might be the easiest way to do the question. It's going to take a little bit longer to do than, let's say, question 3, which was like a snap. It only took a second to do. So for question 6, what we want to do is start off by graphing the 3 points. All right. Great idea to label it too. And then just double check to make sure that you graphed it right. 6, 8, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So it looks pretty good. And 8, 4. Yep, we're good. All right, perpendicular bisectors. Okay, so we need to find the perpendicular bisector of BC. If it's going to be a perpendicular bisector, then it has to go through the midpoint of BC. Perpendicular bisectors do two things. They go through a midpoint and they create a perpendicular segment. So we know that the line we're trying to create goes like this. And I know it exactly goes like this because I can figure out the slope of BC. The slope of BC is down 2 over 1, down 2 over 1. So that's the slope of BC. The slope that I'm looking for that red line, would have to be the negative reciprocal. So 1/2, I flip the fraction, and I'm going to change the sign to a positive. So if I actually sketched out a slope of 1/2, I end up getting this red line right here. The y-intercept of that red line, by the way, is 2.5, and the slope is 1/2. So the equation would be y equals 1/2 x plus 2.5. And if you look at the top of the page, there's only one answer that has the slope of being 1/2. So you could have actually stopped the question once you found out what the slope was, and you did not even need to put down the y-intercept to get it right. So choice 3 would be the right answer. All right. Okay, looking at question 7, they're asking us to build an equation that will be parallel to this equation here. And it has to go through the point 6, 1. There's a few ways to work the question out. I think the easiest way is just to follow my hint and get y by itself in the equation that they gave me. When I get y by itself, I'll be able to figure out what the slope of the equation is. So you want to subtract 4 from both sides. That gets it started in the right direction, and then divide both sides by 2. this would give me 3/2 x minus 2 equals y. So the equation they handed me off said that, I had this is basically this equation right here now. And the slope of this equation is 3/2. If I'm looking for something that's parallel to this one, it also has to have the same slope. So right off the bat I know it's got to be either choice 3 or choice 4, because it's the only one that, these are the only choices that have 3/2. And there's a couple ways to finish things off. You could just plug 6 and 1 into both equations and find out which one goes through 6, 1. Or another way to do the question is just to follow my suggestion right here, is to use y equals mx plus b to figure out which answer it's going to be. So if you have y equals mx plus b, and we know the slope has got to be 3/2, and from the information that's given to us at the very beginning, we know that x is 6 and y is 1. We can use that information to help us find out what b is. So we've got 3/2 times 6. Well, 3 times 6 is 18. 18 divided by 2 is 9. So we get 1 equals 9 plus b. Subtract 9 from both sides, and b equals -8. So the correct answer would have to be choice 3. Remember on these questions too, if you can get it down to 1 or 2 choices, at least gives you a fighting chance to actually get the question right. So sometimes you might not be able to get the entire thing, and that's going to happen from time to time, but just keep on fighting for it and seeing if you can narrow down the choices correctly. Question 8 is an interesting one to me, because a lot of students will just look at it and try to figure out what the answer is just based on, like, oh, this one's probably equilateral. Or a student might say, well, none of these are labeled the same. They're all labeled differently, so it must be scalene. So there's a lot of places where students can get themselves into trouble, and this is one where a student will just jump into it and just say, oh, I must know what it is just by looking at it. Just as the hint says, you have to actually do a lot of work here to actually figure out which is the correct answer. They're all interior angles to a triangle, so all angles together inside a triangle always add up to 180 degrees. That's a fact that will definitely be on a geometry exam. It's one of the more important facts that gets tested on every single year. It's one of the basic facts of geometry. So 5x, 4x, and 3x together makes 9, 10, 11, 12x. And then 1 and -16, or -17 make -16. -16 and -20 make -36 equals 180. So you just got to continue solving for x. So we add 36 to both sides, which would give you 216 equals 12x. Divide both sides by 12. How many times does 12 go into 216? $18 times. So x is 18, and now you still have to take that answer and plug it into each piece. So if x is 18, 3 times 18 is, let's see, it's 30, it's 54 plus 1 is 55 degrees. 4 times 18 minus 17 would be also 55 degrees, because 8 times is 40, it's 32. Minus 17. Let's make sure this is right. So 62, yeah, equals 55. We don't even have to find the last angle out. We got two angles that are the same. They're not 60 degrees, so it can't be equilateral. It can't be scalene. Scalene has all three angles differently. A right triangle can only have two angles the same if both angles are 45 degrees. So it has to be isosceles. Two angles are the same and one angle is different. For question number 9, they're asking me to find out some information about a new triangle that's formed when an old triangle is rotated 180 degrees. When you rotate something, if I rotate the paper 180 degrees, if I'm just rotating, if I'm not changing the size at all, the original triangle will look exactly the same as the old one, except it will be, in this case, upside down if you're rotating 180 degrees. So for this question right here, you don't have to actually perform the rotation. If you know that when you rotate an object, it keeps it exactly the same size and same shape, all you'd have to do is come up with a sketch for it to find out what kind of triangle it is. So I would just do that either on a sheet of scrap paper, or probably the better bet would be to do it on a sheet of graph paper, but I'll just use the space that I have here to graph it out. 2, 3, 4, 5, comma 2, and 5, 5. And just by the looks of things right off the bat, even with this very poor sketch, I'll know what kind of triangle it has to be. The original triangle is not a right triangle. It's not isosceles. It's not acute. It's obtuse because angle B is very large. So if I take that picture right there and I rotate it 180 degrees, it'll still be obtuse. Okay, with question 10, they want the negation of 1 as a prime number. Well, the opposite of prime is not a prime. That's what negation means, is to find the opposite. So it's one of those two things. 1 is not a prime number. That is correct. The prime numbers are numbers like 2, 3, 5, 7, and 11. Prime numbers can only be divided by 1 in themselves. The lowest prime number is 2, and the only even prime number is 2. Composite numbers are the numbers that fill in the gaps, like 4 and 6, 8 and 9 and 10 and 12. The lowest composite number is 4. 1 is neither prime or composite. It's just a definition. For question number 11, they're giving me the coordinates of the center of a circle, and they're giving me, they asked me to find what the coordinates of the center of a circle are. So to do that, probably the best thing to do is to sketch out the 2 points that they gave me. But another idea, which is a lot faster, is just to average the x's together and average the y's. Well, the x's for question number 11 are 8 and -3. When you average two numbers together, you just add them together and divide by 2. So I get 5 divided by 2. So 5 divided by 2 is 2.5. So it has to be one of these two choices here. Now average the y's together. The y's guys here are -4 and 2. If I add those together, -4 plus 2, I get -2. And then divide by 2, which gives me -1. So the correct choice is choice 2. And you can actually graph it to actually see it if you wanted to. For question 12, they want to know the length of the side of a square. If I gave you these coordinates right here. So you can graph all 4 points. As it turns out, you only need 2 of the points. But it's fun to graph, so graph some more. Okay, so we got a square. Looks like a square, so it must be right. They wanted to find out how long each side is. And the hint that I gave below says that what you want to use is the Pythagorean theorem to figure out that diagonal distance. So what you can create is you can create a right triangle on the outside of that square and just count the distance. The vertical distance is 2 and the horizontal distance is 1, 2, 3, 4, 5, 6. So it's a 2 by 6 right triangle. And if you're looking for that last side right there, it's just the Pythagorean theorem to figure it out. 6 squared plus 2 squared equals c squared. So 36 plus 4 squared equals c squared. So if you remember how the Pythagorean theorem works, so c is equal to radical 40. Let's look at the choices that are there. None of them say radical 40. So there's 2 options. You could either try to break down that radical, or you just use the calculator. Most teachers and students feel comfortable with this method of breaking down a radical. It's not my particularly favorite way to do it, but if you had radical 40, it's the same thing as making a factor tree like that. 2 times 2 times 2 times 5. And then the rule is for every pair, 1 comes out. So it would be 2 times radical 2 times 5, which is 2 radical 10. And using the calculator is the easiest way to probably finish off the question, looking for the one that's equivalent to radical 40, and it's 2 radical 10 is the answer. Okay, in question 13, looking for the perpendicular bisector of AD, or they're telling you that there's a perpendicular bisector, which cannot always be proven. Alright, so because it's a perpendicular bisector, we know that C is the midpoint of AD, so those 2 sides have to be the same. So it's not the first choice. We're looking for the one that's not necessarily true. We also know that this is a right angle and this is a right angle. And if they're right angles, they have to be congruent to each other. So this would be correct, but we're looking for the one that's not correct. Would these 2 triangles have to be congruent to each other? Would that have to be true? Well, if you think back to proving with triangles, BC is congruent to itself because of the reflexive property. So you've got a side angle side matching up with a side angle side. So definitely the 2 triangles would have to be congruent to each other. So that's correct that they're congruent, but we're looking for the one that's not correct. So BC and CD, they don't have to be the same size. In this picture, they sort of look the same size, but it could have also been exaggerated this way with the drawing to show that it's possible to draw this situation here, but draw it in a way so that everything else is still the same except BC and CD are different sizes. For question 14, alright, so for question 14, my suggestion is to just draw a picture of what's happening there. Draw a picture where there's 2 angles that are the same and that one angle is obtuse. Well, if 2 angles are the same, it has to be an isosceles triangle. So I'm going to draw an isosceles triangle where angle A and B are the base angles and they're the same size. The vertex angle has to be an obtuse angle, And there's the picture of what's happening there. Obtuse means bigger than 90 degrees. So this is the biggest angle, so it must mean that AB is the biggest side. All the other ones, well, it could be choice 4 also. Let's take a look at that. AC has to be the same as CB. Oh, AB is the longest side. So it has to, there's only one that says AB is the longest side. It's choice 2. All right, question 15. Here's the word median. Medians create midpoints. So these two sides are exactly the same. Which statement's always true? That AD is congruent to DB. It's the first one that's there. That's a quick one. If you just know your definitions, bang, done. Question 16. There's talking about a angle bisector being created. An angle bisector creates two angles that are the same. So that's 30 degrees, that's 30 degrees. This was done with a compass, but you don't have to do the construction. All you have to do is take a look at the picture and see which of the following is not true. Again, stay on your toes with this. We're looking for the one that's not true. Is EBF half of ABC? Yeah. We're looking for the one that's not true. Is DBF half of ABC? Yes. Is EBF the same as ABC? That's false. Which is the one we're looking for. Okay, next picture, next page. Question 17 says to do a transformation of reflecting over the y-axis. That can be a really easy one to do without looking at the grid. 2, -3 is the point we're starting off with in quadrant 4. And it says you're reflecting over the y-axis. When you reflect over the y-axis, it will flip it over the y-axis here, giving your answer over here at -2, -3. The much easier way to do is just have that rule memorized. When we reflect over the y-axis, the y stays the same, but the x will change its sign. Question 18. They're asking me to do 2 transformations to the same point. Sometimes that's best handled by just looking at the picture and working it that way. Remember with the compositions, with this composition dot right here, with any kind of composition dot, you always begin with the item to the right and go to the left. So they want me to start off with 4, 2. And the very first thing they want me to do with it is reflect it over the line y = x. So if you know your reflecting rules well, the line y = x goes like this. When you reflect over the line y = x, the y becomes the x and the x becomes the y. So if we started with 4, 2, when we reflect it, it'll reflect over the line y = x and give us 2, 4. So now that new point is at that location there. That's the first part of the transformation. The second part said to rotate it 90 degrees. Well, in my eyes, the easiest way to do a rotation of 90 degrees is just take your paper and give it a quarter turn or a quarter twist to the left. The positive rotations are always spinning to the left. When I do that, I could see that my new point ended up at -4, +2. So I'm just going to jot that down because it's the answer. -4, +2. It's really easy to make mistakes, small mistakes. -4, +2. I easily could have just gone, 4 negative 2, like I just might have thought of it wrong. So take your time with this. Don't be in such a rush to finish it off. Do a good job. Okay, question 19, getting to some questions that maybe take a little bit longer to do. Another composition of functions. So just as I suggested to in the last question and in the hint, always begin with the one on the right first and then the one on the left second, and you're working that out. It says using the axes below is optional. Well, I might take that option and not show the work on the grid, but if we work the question out just on the side of the paper, it'll probably be just as good. So, and it'll be quicker, and quicker is good sometimes, right? So I'm sure you have other things that you need to do too, study for, and just hang out with your friends or something. So let's see, they want me to do a transformation of 7, 5, which means add 7 to all the x's. So every x is going to get 7 higher than it used to be. So negative 6 plus 7 would be positive 1. Negative 1 plus 7 would be 6. Negative 2 plus 7 would be 5. And negative 4 plus 7 would be 3. Again, don't hesitate to use your calculator to help you out. The 5 down here in 7 comma 5 means to add 5 to all of the y's that are there. So I'm going to take each y and add 5 to it. So negative 3 becomes 2. Negative 1, if I'm adding 5 to it, gives me 4 for both. All right, that's the first part of it. Now we have to reflect over the x-axis. When you reflect over the x-axis, you're going to get four new points. Reflecting over the x-axis, it's the x-coordinate that stays the same and the y that changes. It's okay to use the graph to do this. It's just much faster just to know your rules though. So reflecting over the x-axis, it's the x that stays the same, and just the y is going to change on each. Change its sign. And doing it on the graph is nice because seeing is believing. Okay, a couple more pages to go. Alright, question 20 asks you to do a proof. And with a proof, it's a good idea to organize yourself in a nice way. So I'm going to do that here for you. We got statements, things that are true. And we got the reasons next to the statements of why they're true. There's three givens here. You're given a triangle. You're given that BD bisects ABC, and you're given that there's two segments that are perpendicular. The first one, that triangle ABC is a triangle, you don't have to list that, but if you did, it's fine. So the first sentence was that the first important given is that BD bisects angle ABC. And the second important given is that BD is perpendicular to AC. Some teachers don't have their students list the givens at the very beginning, all the givens. I like to just have the givens listed to start off with. So your teacher might do it in a different order, and that's totally fine because it's also an effective way to do the question. But this is the way I like to handle it, by listing my givens right off the very bat. All right, take the first given. It says that BD bisects ABC. So BD is bisecting angle ABC. So BD is splitting angle ABC in half. So I'm going to draw that on my picture, is that these two angles have to be the same. Because BD split the big angle into two pieces that are exactly the same. So that's what I know. is I know that those two angles that I marked are the same. I could write that down here. That angle CBD is the same as angle ABD. Why was it true? It was the bisector that made it true. So the bisector creates two congruent angles. Okay, line 4 is to use the fact that there is perpendicular segments occurring. BD and AC are perpendicular to each other. Since they're perpendicular to each other, I know they both have to be right angles on both parts of the picture, here and here. So I gotta get writing. Okay. First of all, what does perpendicular create? Perpendicular creates right angles. So I write down where the two right angles are in the picture. Angle CDB and angle ADB are right angles. Because they're both right angles, I know that they have to be congruent to each other. So angle CDB is congruent to angle ADB, and the reason is all right angles are congruent. So I'm trying to prove this fact up here, that AB is the same as CD or CB. To do that, just as it says in the hint, if I prove that the two triangles are congruent, then by corresponding parts of congruent triangles, those two sides have to be the same. And if I look at my picture right now, all I'm sitting on is two angles that match up and two other angles that match up. An angle is not a way to prove that triangles are congruent, but angle side angle sure is. And if I take a look at that segment right down the middle, BD is shared by both triangles. So BD is congruent to itself, and that completes the ASA pattern. So to do that, I would just write down that BD is congruent to itself by the reflexive property. Reflexive, and then I'm right there at the very end. The two triangles have to be congruent to each other. Triangle ABD must be congruent to triangle CDB. The reason is because of angle side angle. And now that I've got two triangles that are congruent, corresponding parts of congruent triangles are congruent. Oh, I guess didn't get my code written right. It's corresponding parts of congruent triangles are congruent. You could write it out in words. What it basically means is if two triangles are the same, then all the matching parts have to be the same. So that's why AB has to be the same as CB. All right. Okay, for question 21, they're giving me three angles in a triangle, three interior angles. And the fact that unites them together is that they always will add up to or sum to 180 degrees. So if I just start by building an equation this way, I'm on the right track to solve this question. 3 angles add up to be 180. Now this equation right here is very, very long. You can make it a lot smaller by combining like terms. X squared cannot get combined with anything else that's there. It's the only quadratic term. Okay, the 11x and the 13x can be brought together to make 24x. And now just do some adding of the numbers. 12 and 5 make 17. 17 and negative 17 make 0. So that's good news. So our gigantic equation changed into a very small equation right here. And because it's a quadratic equation, because there's an x squared involved, one technique to handle this is to get rid of the 180 and bring it to the other side and make it negative so that you can get a 0 on this side so you can do some factoring for the solution. So subtract 180 from both sides is a good way to begin. And because we've got the 0 on the right hand side, it means we can try to solve this thing, or solve this equation by factoring. So I use x and x. If I take a look at the signs, the last sign is negative. Two numbers that multiply to make a negative number mean that one sign has to be positive and the next one has to be negative. I'm looking for two numbers that will add to 24 and that will multiply to make negative 180. Figuring that out is not going to be very easy because 180 is quite a large number for these kinds of questions. Making a list of numbers that make 180 degrees when you multiply them together is a good way to begin. So numbers that multiply to make 180, 1 and 180, 2 times 90, 3 times 60, 4 times 45, and I could just make a list of all the ones that multiply to make 180. So far, do any of these add up to make 24? Nope. Keep in mind one will be positive and one will be negative, so really they'll subtract to make 24. So I don't have it just yet. 6 times 30 could make 24 when I subtract them from each other. Yeah. So 6 times 30 is 180. And if I add them together, I could get a 24 as long as I put 30 with the positive and the 6 with the negative. Okay, remember you're continuing to solve this. So you get two answers for the time being, negative 30 and positive 6. And when you're solving a quadratic equation with some geometric meaning, sometimes both answers will work out, sometimes only one of them will work out, and occasionally none of them will work out. By working out, I mean if you plug these in to the physical setting, you should get positive values because these are angle measurements. If I plug in negative 30 to 11 times negative 30 plus 5, that'll give me a negative answer. So I know that this answer here must be rejected because it's not giving me an answer that makes any sense. So 6 must be the true answer for x. And I'm still not done. There's a lot of work involved. I got to take that 6 and plug it in to each of the situations here. So 6 squared plus 12 is 36 plus 12, which is 48 degrees. So the measurement of angle A is 48 degrees. If x is 6, and I'm plugging that in for B, I get 66 plus 5, which would be 71 degrees. So the measurement of angle B is 71 degrees. And then I have one more to plug in. 13 times 6 minus 17. So 13 times 6 is 78. And 78 minus 17 gives me the measurement of angle C is also, or is 61 degrees. I could double check my arithmetic by seeing if these three angles add up to make 180 degrees. And will they, let's see, so 109 and 71 make 180. So the arithmetic is correct. And that's not what they wanted me to find. They didn't want me to find all the angles. They wanted me to find the longest side. The longest side is always across from the longest angle, or the biggest angle. So maybe drawing a picture of it would be the best way to finish it off with. So I got 3 angles. I get 71 is angle B. That's my biggest angle. 61 is angle C. And 48 is my smallest angle, angle A. I'm looking for the longest side. Well, the longest side is always going to be across from the longest angle. So the longest angle is 71. The longest side is AC. So AC is the biggest angle. That's the end of the question, and it's the end of the practice. So good luck studying, and hopefully you got something out of this. Good luck.